Hello everyone. In this video, we will see validate binary search tree problem. So here we are given a root of a binary tree and we have to determine whether it is a valid binary search tree or not. The definition of a valid binary search tree is as follows. Basically, for a binary tree to be valid binary search tree, the left subtree of the node contains only nodes with keys less than the node's keys. So in this example, as you can see, the left subtree always contains the keys that are less than the current node's key, and the right subtree of the node contains only nodes with keys which are greater than node's keys. So as you can see, the right subtree contains the node's value as 3, and it is always greater than the current node's value. And in this case, basically we will return true as this is a valid binary search tree. In this case, as you can see in the right subtree of this 5, there are nodes like for 3 and 4 which are less than 5, and hence this is not a valid binary search tree, and in this case we should return false. So if you remember the property of our binary search tree, the in-order traversal is always in sorted order. Here we will make use of this property, and we will for the given tree we will do the in-order traversal, and if that in-order traversal is correctly in increasing sorted order, in that case we will return true, otherwise we will return false. So for example, in this case, when we start doing the in-order traversal, the in-order traversal will be as follows, like 1, then 5, then 3, then 4, and then 6. So as you can see, we can clearly see that 5 is greater than these two nodes 3 and 4. Hence, this is not in increasing sorted order, and that's why for this tree we will return false. So basically, while making the in-order traversal, we will have to check previous node uh, whether the previous node is strictly less than our current node or not. If this condition is not matching, in that case we will have to return false, otherwise we will return true. If we check the source code, we are given the root of the binary tree, and we return true if it is a valid binary search tree, and we return false if it is not a valid binary search tree. So as you can see, this is like we are making non-recursive in order traversal, and for that we are initializing the stack, and also we need to keep track of the previous element for this condition. To check this condition, we need to keep track of the previous element in our in order traversal, and then we start our non-recursive in order traversal. We go on pushing the elements we go on pushing the element on the stack, and then go on traversing till the leftmost node. Once we reach that leftmost node, we pop that node, and we check whether if the previous node is not null, and if its value is greater than or equal to root's value, that means this condition is not true, and hence we return false. uh, if this condition is not matching, that means that there is no problem with current node, and we proceed with our in order traversal. We basically update our previous reference to our current node's reference, and then we go to the right of that current node, and then we continue with our in order traversal. And if this condition is never made If this condition is never matched, that means that we successfully completed our in order traversal, and there was no such previous node where its value was greater than or equal to current node. That means our entire in order traversal is in increasingly sorted fashion, and that's why we return true as it is a valid binary search tree. as we are making the we have to make complete in order traversal in this case. Hence we are visiting each node, and hence overall time complexity of this problem is O of n.